Hi, my name is Amy Zhang, and I'm presenting this work in collaboration with Michael Muller and Dakuo Wang of IBM. The focus of our work is on data science within organizations and how data science projects today are often conducted in collaborative teams instead of alone. These teams often involve multiple roles with unique skills and domain expertise, not always technical, and they contribute at different stages of the typical data science workflow. Despite this, many tools and studies today still focus on individual data scientists. Even when they do incorporate collaboration, they oftentimes focus only on technical roles and technical stages of the workflow. So in this work, we provide a richer account of collaboration in data science teams by examining a broader range of roles, including technical ones and non-technical ones, and a broader set of stages of the data science workflow. To gather data on collaboration, we conducted a study in early 2019 with 183 people who have worked in data science teams within the organization IBM. We asked questions about the roles people collaborated with and in what stages of the workflow, the tools people use for collaboration, as well as people's practices and expectations around data and code sharing and reuse. So then turning towards results regarding data science roles, we overall found high self-reported rates of collaboration across all the roles we examined. People reported collaborations across roles that were overall reciprocal and equally distributed, with the one exception of communicators, who reported high collaboration with others, while other roles reported low rates of collaboration with communicators. Next, we asked about collaboration in each stage of the data science workflow. We found that the role of researchers are active at every stage of the workflow, perhaps acting to guide the project overall. To a lesser extent, this was also true for domain experts who may be consistently called on to consult in every stage. We found that roles like managers and communicators are generally active in non-technical stages and not very active in technical stages, and this was the opposite for engineers. And in the case of the bias mitigation stage in particular, we were interested to find that this was mostly treated as a technical matter with little involvement from managers or communicators. Turning towards tools, we conducted qualitative coding of people's free response questions, asking what tools they would use in different stages of the workflow, and came up with the following categories. Anything from Slack for discussion, to Python for coding, to Box for file sharing. Then we mapped these categories across the stages of the workflow. Some things were unsurprising, like that code-related tools seem to fill in for asynchronous discussion during the more technical stages of the workflow. We also noted relatively lower usage of tools related to documentation, presentation, or discussion in some important stages, where a lot of consequential decisions get made, such as feature engineering and bias mitigation. To better understand how the use of certain tools relate to collaborative practices, we clustered our respondents according to what tools they stated they used. We came up with 3 main tools profiles, including project managed, and these were people who heavily used project and team-oriented tools like GitHub and Slack. Interactive, who mostly used interactive code editors like Jupyter Notebook, and also the scripted profile, who made greater use of one-off scripts in Python. This cluster was also mostly engineers. We found that across all profiles, people stated they read and reused other people's code more often than other people's data. But interestingly, when we asked about their expectations that other people would use their code or data, the project managed profile actually had high expectations around data reuse, while the interactive and scripted profiles had low expectations around data reuse. This interestingly carried over to documentation practices, which was overall lower for data than code, though we did see the project managed profile made use of the strategy of external documents pretty frequently to document data. So in summary, we found that data science workers collaborate extensively and in every stage of the data science workflow. Documentation and discussion, especially with non-technical roles, may be insufficient in certain stages like feature engineering and bias mitigation. Practices, expectations, and toolings for sharing and reuse around data is less developed than for code. And in conclusion, we need more data science tools that can capture the provenance of and decisions and discussions around both data and code for both technical and non-technical collaborators. Thank you, and you can contact us here.